I'm Mark Donovan. I am the Director of Commercial Applications. Also online here, we've got, he's monitoring the chat, is Dan Pelletier. He is the Applications Engineering Manager. And today we're going to talk about future-proofing your audio installations. And you know, when you start talking about future-proofing audio installations, that's kind of one of those you know, one of those things you hear a lot. It's like, what does that really mean? What are the things that you really have to, you know, pay attention to when you're talking about future proofing? And we're going to go through that. We're going to go through kind of your higher concepts of future proofing a system. And then we're actually going to go through talking about System 10 Pro, engineered sound wireless, and our ceiling array, and talk about how some of those features lend themselves very well to future-proofing systems. And then we're actually going to walk through a couple of little scenarios, you know, common types of things that we've run across in the applications engineering department, you know, that some of these products and their features could solve the problems for you. So let me, let's go ahead and get over to the presentation. As I get into my mode here. All right, so future-proofing the system. Really, so what are we talking about when we're doing that? Well, what we're going to do is we're going to put focus on the tools and insights to help you design an audio system that's ready for tomorrow's challenges. It's easy enough when you meet with people, you meet with the actual end users, or if you yourself are an end user, when you sit down that first time to decide what's necessary for it. It's easy to look at what today, what's happening right now, whatever that pain point is today. But we need to start talking about tomorrow's challenges and how we might be able to meet some of that. And we're going to look at these three foundational principles when we're talking about future-proofing audio design. So there's three, you know, basics to this that we have to focus on. Change slide. One, scalability. Two is flexibility. And three is agility, more specifically integration agility. And I'm going to go through each of these and talk about what I mean. The scalability, we're going to go through this and we'll explore how our different ones have those different concepts and all that too. So we're going to go through how those three concepts apply to System 20 Pro, Engineered Sound Wireless, and AT&T 1061. So let's look at the framework of what we're talking about when we talk about future-proofing thing. It really means that you're building a system that's going to be able to evolve with your needs. And it's going to help, you know, avoid costly redesigns, long-term value to your customer, and support adaptability, the ability to change and do different things. It's definitely, you have to look at the scalability side first. Your system needs to be able to grow with the needs. And that might mean starting with just one microphone in a room and then expanding up to a full suite. Or it may be going with one room and expanding up to multiple rooms. But what we're talking about here in scalability is we need a system that can enable incremental growth without having to just trash the whole thing and start all over again. So that's, you know, kind of the key to scalability. Flexibility, on the other hand, is where we're looking about being able to support a wide range of use cases within that space, adapt to different activities throughout the day. When you're talking about wireless microphones, I think one of the biggest things here is being able to handle variability within the RF wireless spectrum, you know, so that wireless microphones can stay in operation. And then finally, the integration agility. And this is actually a very important one these days, especially as, you know, you start seeing more and more systems out there, control systems, monitoring systems, remote monitoring and access systems, which we'll talk about a little bit later. But we need to be able to evolve with new technologies and workflows. I mean, for those of you who are on this call who may have been in this business for a while, when you think about, you know, the last 15 years, what has happened in control systems, what has QSys and Biamp and all these other DSP companies been doing. So being able to evolve with some of these new workflows is how you're really important to that. And also I think personally, as we move forward, we still have a lot of analog microphones in use. There's still a lot of analog sources in use, but supporting networked audio routing is really going to help you a lot in order to be able to change for future issues and things like that. And of course, remote management and smart control of things. What you're really trying to do by looking forward here is you're trying to avoid major hardware changes. Why is that, important? I mean, AV systems are long-term investments. For those of you who may be end users on this call, you're looking at investing, in many cases, a significant amount of money. And those who are in charge of the pocketbooks there, those who are in charge of paying the bills, expect to see that investment last for some time. So being able to have a system that can adapt to those changes is extremely important, because without future-proofing, without looking at these things, you're looking at costly overhauls, perhaps even relatively early in the life of a system, limited functionality, and of course, frustrated end users. Now, for those of you who are on here that may be integrators, that frustrated end user means an end user that's not going to come back to you for business. For those of you who are the end users, like the IT guys in-house, the frustrated end users, these people are looking at you really hard. And I mean, it's your job to make these things work right. And those frustrated end users can put a lot of pressure on you in that. And obviously that's what we don't want. So we want to look at, what are some of the pitfalls that we can avoid with this. I think first really is, we have people that design only for today's needs. You've got, a CEO comes in and says, I've got this room, we've got 4 people that are going to come sit around this table, we're going to deliver our board meeting, reports across a Zoom call, and that's what we need it to do. And you design your system to do that. But invariably, those things change. And tomorrow they're going to come in and say, well, we've got to do that board meeting, but we also want to do a workshop now. So we're actually going to have about 10 people in the room, and then we're going to have many remote participants. So designing only for that today's needs can put you in a box really, really fast. Also using closed systems and protocols. And by closed systems, I mean kind of like your self-contained systems. I mean, like, for example, Audio-Technica does have some proprietary interface stuff, some proprietary interface between our devices. But what I mean is a system that's closed to the outside world. You do not want to use a system that can't communicate with other devices, whether that's a computer system or a control system or another DSP, because that really limits you to just what that device can do. With our products, with Audio-Technica products, especially the ones we're talking about today, are networked type products, which is, System 20 Pro, Engineered Sound, Wireless, and our 1061 beamforming array. All of that has open APIs. So all of the information, control and monitoring is available to the outside world, so that you can use a control system or a DSP or however you want to access and control that. So I realize that a lot of the things that you may find out there, certainly, again, if you're an end user, an IT person, you may see a lot of things that are really cool and attractive on Amazon and look neat and have great photos and even better prices. But if it's a closed system, you're really painting yourself in a corner. So, really need to look at how it's going to work with everything. And I think also one of the things that people fail to do, a pitfall they fall into, is overlooking network and power infrastructure. That's a big one. So you go into a room and you say, I'm designing this for today. But if you go to expand that, you need to look at, do I have enough ports on my network switch? Does my network switch provide the appropriate level of power at PoE, PoE plus, or plus plus even? Do I have the electrical that may be required to power the different things in here? Do I have enough AC circuits? So these things are kind of the foundational things that you have to look at when you first go into this, to make sure, again, that you don't paint yourself into a corner. So really that's going to help you, the goals here is going to help you design a system that is resilient and it's adaptable and it's ready for what's next, because manufacturers, such as us, we're evolving, we're constantly changing. In fact, we're often doing things like changing firmware on existing devices that actually adds functionality. So, we want to help you out and get to where you're going to be next. So let's talk a little bit about what's next. First thing we're going to talk about is System 20 Pro. Then we're going to go into ES Wireless, and then we're going to go into System or AT&T 1061, the beamforming ceiling array, and we're going to talk a little bit about those and how those three concepts apply to it. So, System 20 Pro, digital wireless system for education, corporate, live events, entry point into what we would call that future-proof audio with that scalability, flexibility, and agility. And it's accessible design without compromising that pro performance. So when you look at those three things, scalable, flexible, agile. So scalable, you can add transmitters as needed to System 20 Pro. Flexible, that frequency agility that they have because they automatically decide what frequency they're going to operate on without end user interface. And then finally, agile is this system actually does have an open API. We actually have QSys plugins for it, and you can integrate this into control ecosystem. So I'm going to take a minute here and actually do a kind of a high-level overview of the System 20 Pro, which is the system that I have in front of me, which also, by the way, that's actually what you're listening to, which I'm talking through this microphone right here. So this is our System 20 Pro. It's a digital wireless system. It operates in the 2.4 gigahertz range. It operates automatically. So what's occurring, this right here in the center, just off the center, this is with the antennas on it, obviously. This is our receiver. But the receiver actually has two-way communication going on with the transmitter and receiver. Because what's happening is the receiver is first looking at the environment to see what's going on. And this is where that frequency agility is going on. So it's seeing in real time what is happening in the RF spectrum. And then it's going to upload a frequency plan to all of the transmitters. And you can actually do as many as 20 transmitters on System 20 Pro. And so then those transmitters will download their audio information. It gets back into the box again. And then it goes through that cycle over and over and over again. So it's constantly looking for interference to avoid. If it's found a nice, comfortable place to be, then it's going to stay there. But if something changes, an example might be somebody walks into the room with a laptop that wasn't there. They're late to the meeting. They walk in, they connect. Now there's a new Wi-Fi connection. If it needs to move because it's all of a sudden stepped on it, it's going to do it. And it actually, because it's communicating between these two devices on two frequencies, a primary and a secondary, a primary and a backup, if that primary gets smashed, that backup errors to pick it up and you'll never hear it. And this is the kind of thing, this has great advantage over, say, some of your older systems, your analog UHF wireless, because this doesn't require user intervention. And it's kind of a bonus on two fronts. First, if you're the installer, you just turn it on. There's no programming of frequency. So this saves you a ton of time. And second, if you're the end user, if something happens, it's going to change on its own. You don't have to touch anything, push any buttons, make any phone calls. This thing's going to handle it just fine for you. And it actually comes with all the different transmitters that you might need for that. So it's got a belt pack transmitter that you can use any one of our like lapel or headset microphones on. It's got a handheld microphone, a hyperdynamic, a hypercardioid dynamic element on this one. It's got a cardioid boundary microphone. This basic hockey puck looking kind of situation. And then you also have this gooseneck base here, which you can use a gooseneck microphone in. Now, I'll kind of go off track just a little bit here, but this is also one of those things where you start talking about wanting to understand your application and needing to know how it's going to be used, not just now, but in the future. So like, for example, this microphone that I'm using right now is a shotgun style microphone that is great for isolation right on the person that it's pointed to me, but it's not good for picking up multiple people. But the advantage, of course, with System 20 here and also ESW when we go into that is if I need to trade that out with another microphone and put one of these boundary mics, which is a cardioid condenser which can easily pick up 2 or 3 people. That's a very simple thing to do to put that into the system. So you can actually adapt to that. In fact, one of the things that gives you a little bit of that flexibility and scalability with System 20 Pro is the ability to actually pair more than one transmitter to a single receive channel. So why is that important when you're talking about how things are going to operate tomorrow in your boardroom? Well, especially this happens when you're talking about presenters. So some presenters like to use a handheld, some presenters like to use a belt pack. But what you can do with System 20 Pro is you can actually assign both of these transmitters to that same receive channel. And that way, whichever one comes on first, whichever one is turned on first, that's the one that's going to take that channel. And so in the terms of future-proofing kind of things, let's say you set up your system and you decided a handheld was going to be the one you were going to use, but then a month later you get, a new member on the board of directors that says, actually, I like using a belt pack with a headset mic. Well, that's fine. All you'll have to do is get the transmitter and you can still pair it in and connect it in with the existing system. So these are the kind of changes, the future changes that I'm talking about that System 20 so it can certainly give you that flexibility to be able to operate. Now, a few other things to note on this. One, you do have charging options. So the handheld and the belt pack actually have drop-in chargers that you can just drop them right in here. The gooseneck and boundary microphone both have USB-C chargers on them right there on the back, so you can charge them. You're talking about a good long battery life, depending on which model, anywhere from 14 to 18 hours. So you've got good battery life throughout the day. When it comes to the receiver, this single half rack piece here is actually a 4-channel receiver. So you can really conserve rack space, but you can easily add on. You could add another one on right next to it to go to 8 channels, or go on again in multiples of 4 all the way up to 20 channels. So it's easy to expand this. And for every 4 channels, you have this cool little feature here, which this is the remote mount receive unit. And this is important because this is going to make life a whole lot simpler when you're installing a system and you need to remote mount antennas. Now, with most wireless systems, you do need to remote mount that antenna. And if you're using a traditional UHF wireless, that can be difficult to deal with. It's expensive. The connectors are different. But with this is just category cable. So again, if I needed to add a second receiver to go from 4 to 8 channels, it's really just a matter of running another Cat5 to support a second receive unit. So it's certainly much simpler. We've looked at that, at how are you going to be able to expand and how are you going to be able to move on. Now, looking at this, going back to the presentation and looking at it, what are your limitations? What considerations do you need to look at when you're talking about System 20 Pro? Well, one of the things is it is limited to 20 channels. And that's within a single space. Now, because it's high frequency, you're talking about 2.4 gigahertz here. Because it's that higher frequency, you could have, 2 channels in this room, or 4 channels in this room, and 4 channels in the next room, and so on and so forth. And by the time it gets to the point where you might have interference, or you might have issues, they'll be far enough apart. But if you're talking about within the same space, a larger boardroom or a conference space for a board of directors or whatever, you are limited to 20 channels here. It's also only an analog audio output. So if you're designing a future system that needs Dante, you want to have a Dante system, well, this one's not going to have that output there. So, if you need that higher channel count, or if you need digital audio, that's where you shift over to engineered sound wireless. Now, engineered sound wireless is purpose-built for meetings and conference spaces. And it does support that Dante and AES-67 for networked audio. In fact, that's the only option you have. There is no analog output on this. And it really is designed for that integration, agility, and remote management. We've got QSys plugins on that. So looking at those 3 points again, scalable, you can add channels to that and transmitters as needed, up to 96 channels. So you can get significantly larger deployments of this. Now, it also has that frequency agility to it, where it is managing its frequency. So it's a decked band wireless, digital enhanced cordless telecommunication, and it has a standard that operates that similar kind of two-way communication between transmitter and receiver to avoid any kind of interference and problems. And then far as integration agility goes, of course, you've got the digital output with Dante audio. You've got an open API. You got plugins for QSys. You got plugins. I believe you also have plugins for Symmetrics. And really, into any control ecosystem, it's pretty simple. So I'm gonna. Well, first of all, you didn't notice because we switched, but go on live here again. I've got the ES wireless in front of me right now, which looks a little bit different. I actually switched over the transmitter. This system has fewer components, and part of that is that this is your receive point, right? This is an 8-channel receive point, and it's got Dante is your only option. You can see it only has a network connection. It's powered by PoE. You don't need PoE plus, it's just PoE. So for every 8 channels of direct band wireless, engineered sound wireless, you're going to need one of these. But that's certainly easy enough to expand on if you're going to go from 8 channels to 16 or whatever like that. You also have a lot of different options for the transmitters. Again, you can see we've got a belt pack transmitter right here. We've got a handheld transmitter, which this one actually has an interchangeable capsule on it. You've got the boundary microphone, which in here there are 2 capsules. One of them is omnidirectional and the other one is cardioid. And then finally, you have the gooseneck mic, which I have over here on my left, which is actually what I'm talking through right now, which you have several different gooseneck lengths, 6 different gooseneck lengths, and 3 different capsules that you can use. Again, on this one, I'm using that shotgun capsule for that better isolation. But you do have all these different options. Now, what do you get in an advantage when you move up from System 20 Pro to this, to engineered sound wireless? Well, one of the things is you actually get quite a bit more battery life. I mean, the minimum battery life on these with the gooseneck is 17 hours. And then you go up to 22 on the boundary, 25 on the belt pack, and 35 on the handheld. So if battery life is a critical function for you, that's one of the things you may want to look at. Charging is a little bit easier here. We've got a very similar charging type for the handheld and the belt pack that you just saw for System 20 Pro. But for the tabletop ones, for the boundary and the gooseneck, you can still use USB-C to charge, but we have these other type of chargers here that you just set them in there. It makes it extremely easy for the end user to put these in there and to charge them. So now programming is also done through these chargers. So I always like to point out that you do have to have one of these chargers with it, even though you do have the USB option for powering it long term. I think an example there might be, maybe you've got somebody, they're doing budget meetings in their boardroom all week long and they just want to leave everything kind of set up out there, then you can leave these transmitters in there and just power them through USB. I mean, you can plug them to a phone charger for all it's worth, and they can operate and charge at the same time. So that makes life very, very simple on that. And again, automatic frequency management is really going to give you a lot here, that it's going to constantly look for that best place to be. It's going to constantly shift, and you can avoid any problems like that. Let's see, now I had mentioned with System 20 Pro that you had that functionality to be able to pair 2 transmitters to 1 receive channel. And you have that exact same functionality on engineered sound wireless. Again, the scenario being, I've got a presenter coming in, but I don't know whether they're going to want to use a handheld or a belt pack. Well, you can provide them with this. Now, what this has as an advantage that System 20 Pro does not is this belt pack, which you can't really see it. So you can see the silver piece here is actually the connector that you could connect any of the headset or lapel mics, but kind of right next to it is a little hole. I doubt you can see it, but that hole is an omnidirectional mic that's built into it. So what this mic has is the ability to be used as a lanyard microphone, so that the microphone is built into it and you don't have to clip a mic to somebody's clothing or around their ear or anything like that. So, moving up into engineered sound wireless also gives you a few other flexible things to be able to deal with it. Like I said, if you got a guest speaker coming in, then, especially if you have a lot of guest speakers that might be coming in for an application, you might want to consider engineered sound wireless, because it's going to give you more flexibility in dealing with those dynamic conditions. So that's kind of a look there at engineered sound wireless, and going into some of the considerations when you're talking about that. It is going to have a higher cost per channel than System 20 Pro. I mean, that's only natural. It's a higher density piece. It's got more channel capability, more battery capability, a lot more flexibility. And also that Dante itself is going to come at a little bit extra cost. And what are the downsides there? Like I said, a little higher cost. It is only Dante output. So if you've got a system where you want to use an analog interface, you're going to have something that breaks that out. Now, that's not impossible to find. There's a lot of people that make it. Pretty much every DSP company out there can take Dante in, and you could break out your audio into an analog output if that were necessary. And we've actually got a device too. We've got a mixer, the ATDM 1012 DAN, which has a Dante interface, which can bring that audio out. So it's certainly there are options for that, but it's just something to keep in mind. The other thing too is, because people ask me now, latency for the ES wireless is a little bit too high for performance audio use. So you're not going to be using this in singing, in house of worship, and things like that. It's got a much higher latency. It's because it's operating in a frequency band that is much narrower, much more restricted, and it basically has to time share its slots within that, so that makes the latency a lot longer. Now, if you're talking about System 20 Pro, the System 20 Pro latencies are in fact low enough to get down and to use for performance. In fact, System 20 Pros got a standard density and a high density mode, which is the difference between the two is latency mode, so that you can decide what's best for you. Now let's talk about what if we don't want to use wireless, because wireless does have its down points. I mean, wireless does tend to be a little bit more expensive per channel as compared to, say, a wired microphone. And also it's battery management, have to make sure things are charged. Now, the beamforming ceiling arrays, now that's something that has come into favor certainly in the last 10 years because it gets around a lot of that. And we, of course, we have our AT&D 1061 beamforming ceiling array. And it really was built for those dynamic multi-use spaces. So it's able to adapt to that real quickly. And for hybrid environments that require clarity in audio and also control. And it's a PoE powered device, so you don't have an extra power supply running it. It's networked audio and very easy to control that. In fact, we have plugins with QSys and Symmetrics and many others. It's certainly easy enough. The APIs, as I mentioned before, are open. So when we go back to those 3 points again, scalable. The cool thing about the AT&D 1061, and I'll get into that a little bit more in a second, is you really do have the ability to use those as a distributed DSP system so that you can actually scale within a room or within a campus and keep things, actually you can save a lot of money in DSP systems using that. And it's still flexible, very configurable for coverage for different zones, for different layouts. If you're doing a classroom type of format today, you're doing a board meeting tomorrow, a panel discussion the day after, it's easy presets that you can reconfigure that. And it's agile when it comes to its integration. We're actually able to integrate that with pan tilt zoom cameras using VISC over IP. So looking at this is actually on the table I have right in front of me here. This is the AT&D 1061. It's a much smaller form factor that you're going to see in a lot of the other ones. It's only a 9-inch square. It does, however, come with a back box mounting kit with all the bezel and tile bridges and everything, so you can still put that into a ceiling tile. Like I said, it comes with all that. And you could also use a projector mount that can actually connect directly to the back of this to hold, put that down on a pole for maybe a higher ceiling so that you can get it into the correct position for operation. And it even has a surface mount plate for this. But I think a couple of things that make this really attractive. One is the zone concept. Now, there are some videos on our YouTube channel actually that cover a lot of these devices, and there's one that goes into a little bit more detail on explaining zones on the AT&D 1061. And what a zone is you're basically telling the microphone to use one of its 6 beams to cover a specific area in the space, to listen to to see if someone is talking, and then to activate that beam to bring it up to, its operating level while that person is talking, and then go kind of into a standby level if nobody in that zone is talking. So this is automatically managing which microphones, which zones are turned on. Again, you have 6 different beams that can go around to, actually you can create 32 different activation zones throughout a space. And the space that this can cover is a 5-meter radius. So that's a pretty good size. I mean, 32-foot circle. Now it is a radius, right? So it's going to be that hemispherical coverage. And one of your big concerns on that is, how high do you go with it? And people always ask the question, how high can I mount it? Well, it's actually a simple geometry, I guess, is as you go higher, you're coming into the bottom part of that hemisphere. So your coverage area for a fixed seated talker is going to shrink as you get higher and higher and higher. And so if I were to mount that 16 feet up, above my head, and I'm here at 4 feet, you're going to probably pick up just me. So, that's what you really have to take into consideration with that. As far as the integration with the PTZ cameras, I think a cool thing to point out here is that actually was not an included function in the device when we launched it. That was an upgrade. That was a free upgrade using simple firmware that allowed this to talk directly to PTZ cameras. So again, through your kind of zone-based system, it's a different kind of zones, what we call camera areas. Through your zone-based system, you can tell a camera to recall a preset based on where someone is talking. And you don't have to have additional hardware or software running in between it. It just naturally talks using, like I said, VSCO over IP, which is about as close to a standard as you're going to get with pan tilt zoom cameras. But that's going to really allow you to elevate a room. So maybe today you're not using, pan tilt zoom cameras to do different shots within a room, but it happens all the time. Maybe you're the head of IT and you get a call that says, hey, the CEO would really like a camera that moves around to the different talkers within a room. Well, for us, if you're using the AT&T 1061, using this beamforming array, it's just a matter of changing the configuration and getting a pan tilt zoom camera. And then you can actually do that without, again, having to scrap your entire system or start all over or go with some really expensive solutions. And again, you're protecting that investment that you've made. So the AT&T 1061 is really one of those devices, I think, that adds a lot of flexibility. Going back a little bit, because I had mentioned this about the scalability side of things, is within each one of these microphones is actually all the processing you would need. So it has an automatic mixer for those 6 beams. It has echo canceling, noise cancellation, and all that built into it so that it can take those 6 beams and combine them down to a single output. So how is that scalable? Well, actually, in the setups on this, you can actually connect this so that multiple devices are working together in unison. And it's all going to have this communication going through the network. So let's say, for example, I've got a classroom that is a little bit bigger than one will need to cover. You could actually use 4 of these in there. And by communicating through the network, each one having a home run to a network switch to power it, obviously, and also to route the Dante audio. But you can have this operate as a distributed DSP system. So each one of them handling the DSP within their device and then handling all that information back to the primary device so that it can mix it down into just one coherent audio output to go out from there. And in fact, it can cover up to 20 of them. So you're actually scalable up to 20 ceiling arrays on this. So having that distributed DSP system, having that communication between them is actually really key for scalability on that one. Now, going back into the presentation here, looking at some of the things, what are some of the considerations you have to do? And I kind of mentioned this when I talked about the coverage area. Mounting height and position is critical for the success of this microphone. If you go too high, again, you've got that hemispherical coverage. If you keep going too high, that coverage area gets smaller and smaller. You mount that thing over 20 feet, and you're not going to pick up anybody who's seated. So you do have to worry about mounting height and its position. And one of the things that kind of goes hand in hand with that is that audio quality is great on these microphones. It does an excellent job of picking up and filtering and giving you good, clean audio, but it's never going to be as good as close miking. The best mic, out there is going to be the one that's closest to the mouth because that's going to give you, you know, that more direct sound and less of that sound from outside that could, cause problems or make people, have a difficult time understanding or hearing what's going on. Now, I have had people say, well, can I put the AT&T 1061, for example, over a choir in a church? And the answer is no. Your latency is a little too high for any performance audio use. And the reason being is because you've got a lot of processing going on. First of all, that beam forming and beam directing and zone activation, that all takes an immense amount of processing, and processing equals time. And so that latency just is really not going to work out for that. This is meant for the conference type of space, a conference room, boardroom, classroom especially. And for that communication, that voice communication, it does an excellent job of preserving that voice clarity. Now, let's talk a little bit more about some of the concepts that we've gone over here and kind of bring it all together and how we need to look at systems that are truly future ready. Again, avoid those all-in-one systems that limit scalability. And again, I didn't point out any, particular brand names or anything, but, you can always find something cheaper on Amazon, and there's always a reason for that. You can get these all-in-one boxes that look awesome, but you really need to avoid that because you just will not get around scalability on that one. You just can't get into them. They're closed systems. You can't talk to other systems with them. You really need to choose components that can be upgraded or expanded independently. So if I need to put more microphones in, that's an easy thing to do with any of the products that we talked about today. Now, when it comes to the network, and this is something, like I said, the first system we talked about, System 20 Pro, does not have networked audio. And really, that's kind of a cost-saving thing. It still has a lot of those key features that we're looking at for future-proofed audio. But when you really start talking about where's my system going to be in 5 years or 10 years or 15 years, that networked audio infrastructure is going to be key. So if you have not, or if you're only now looking at using Dante as your backbone, I really do recommend it because it just simplifies routing. It reduces cabling. When you're routing analog audio, you're talking about, let's say I have a conference system that I'm doing analog audio at. You're talking at least 3 different cables. You're talking about a microphone cable, a network cable, and you're talking about a speaker cable. So you've got these different cables with their different connection types and the different disciplines it requires to make these connections. Or you can choose products that are doing networked audio for their backbone, and then you only have one to deal with. You have that single network cable. And it also gives you a lot more. This enables centralized control and monitoring. Now, for you on the call who may be integrators, this becomes key, especially if you're living in one of those dense urban areas. If you're an integrator in New York City, I don't have to tell you about how difficult it is to roll a truck downtown and what the cost involved in that is. And this is true in any of these large cities across the country. But if you have this system set up and you have the network setup, the network infrastructure, you can actually get into these systems remotely and see how they're performing, see what's going on, tweak them remotely if you need to, change them remotely. When you have a request from a customer that says, hey, we've got a new configuration now, we're actually using this room for classrooms as well, fine, you could actually get into that remotely and change the ceiling array to have different zones and do all that. So having that centralized control and monitoring is I think, one of the best benefits of having that. I think embrace remote management. I'm sure you've heard it all. I don't think this is new news to anybody, but it's really essential for, not just that urban type of situation we just talked about, but also for multi-room or multi-site deployments. If you're at a university and you're deploying 100 rooms, and I need to tell you this, you can't run around from room to room to room and connect in each different room to each of these devices. You need to be able to see them all. You need to be able to manage them, push firmware updates, see their status, do changes to them, all of that remotely. And it also gives you the chance to troubleshoot things from that central location. And really, that I think is one of the most important aspects, I think, of having, network-centric technology, which all of these devices that we've talked about today, you can do that. You can, look at them all remotely. You can push firmware updates remotely. You can troubleshoot and configure remotely. Now, wireless system planning becomes a little bit different. There are some additional concerns, some additional things you need to look at. If you have chosen that you're going to use wireless, be it System 20 Pro or engineered sound wireless, there are a few things you need to consider. First off, avoid maxing out that channel capacity. If you're going in to a room that needs 20 microphones and you look at it and say, oh, I can use System 20 Pro, that's 20 microphones. Yes, you can. That leaves you no room at all for future expansion. And it also puts you at a risk of performance issue. If you're running at its maximum capacity with any wireless system, whether it's Audio-Technica's or any one of our competitors, when you're running at that maximum capacity, that means those devices are filling up that maximum RF bandwidth that they're allotted. So if something happens, some kind of interference comes in, there is a higher chance of having a dropout, of knocking one of those transmitters off if you're at that maximum channel capacity. So as you start to approach that, and there's no real rule as to what that number or percentage might be, but as you start approaching that maximum, you may want to start considering the next step up just to save yourself headaches down the road and maintain that future-proof ability in that. So let's talk about a couple of examples, and we actually have a lot of case studies on our website, PDFs that you can download, that talk about some of these different kinds of things. For example, in some of these wireless type of situations, you may have classrooms that are installed in phases, where you're doing 2 classrooms here, then another 2 there. And you want to be able to have something that can manage that very easily. And so you could choose System 20 Pro or ESW based on your channel needs and whether or not you have Dante. But that automatic frequency management is going to help make setup a whole lot easier. So, if you haven't done this, if you're setting up a typical UHF TV band wireless system, you'll go in, you'll put, say, 2 channels into this room, and you'll select 2 channels that are clear frequencies, and then you'll light them off, and hopefully that will all work fine. But then, now you come in to put 2 microphones in the room next to it, you need to find 2 frequencies, not only that don't have any kind of stuff going on in the air, but are not going to interfere with the 2 you put on previously. And this gets exponentially worse as you go to higher channel counts. And if I'm going into a building that has 100 or more channels of wireless, an example actually is a courthouse that we did that actually had 170, I think it was 177 channels of analog UHF wireless. That was not an easy task to build that frequency plan. And we were able to do it, but it is not something that's simple. And especially for you guys, you IT guys, or even just the integrators who are just looking to do some quick stuff. Time is money, so choosing something that's going to be able to much more easily deal with the environment and to do so automatically is just going to save you a ton of time. Now, in a corporate type of thing, you might be looking at an AT&D 1061, that ceiling array, because you can do varying meeting formats. You can do classroom, it can actually be set up so that you have those reconfigurable zones so that it can follow an instructor that's going back and forth through the front of the classroom to keep that beam centered on them so that the audio is going down the far side. And then you can change it so that it's a panel discussion, or then it's a board meeting and things like that. It's very easy to meet those requirements of varying formats because of those presets. Actually, virtually immediately when you trigger the preset on that it changes all that configuration instantly. And it also supports that VISC over IP, which we talked about earlier. If you need it at the time, or maybe in the future you would like to, you can easily communicate not only with single cameras, which I talked about, but there are also multiple other devices out there, such as Lumens has their Cam Connect, and Aver has a little box, the MT300. These are multi-camera devices, so that you can actually do things like camera switching and masking and all that. You can get pretty intense all the way up to using something like ACPR, your camera preset management from QSys, because we are included with that plugin as well. So this gives you a lot of flexibility there. And then you've got things like a hybrid event space, something that you've got, a lot of different things can happen. And you can start up with a basic setup of using something like engineered sound wireless, and then you can scale up because you only need to add one of those, PoE receivers for every time that you're doing 8 channels. So, these things actually, and I didn't mention this earlier, but they have incredible range on them. So they have 100-meter range in the mid-power mode, which is what they come default. So having one of these in a large event space, and even at that kind of power level and the way that we use things, even stuff like air walls, divisible air walls, is not going to significantly block that RF energy, which is something that some of the older devices on the market out there struggle with. But for ours, it's not. You've got a huge ballroom, mount these devices right up in that center spot, put an 8-channel PoE receiver in, one of those receivers for every 8 channels. It's real easy to route the Dante audio over the existing network to provide that audio to run from any one of those divisible spaces. And you can actually expand it up to 96 channels. So, this is definitely the kind of system you would want to look at if you're talking about one of those hybrid larger event spaces. So the best practices to kind of to sum some of these things up: plan for expansion for day one. Even if whoever you're talking to, whether it's the end user, the actual person that's in the room using it, or you're the IT person, or you're the integrator, plan for that expansion from day one. Even if they don't ask for it, plan for it. Prioritize the interoperability between any given piece of equipment and other pieces of equipment, and keep that firmware and software up to date. Like I mentioned, that camera preset recall, that VISC over IP with our ceiling rate, did not originally come with it. That was a bonus feature that came with a firmware update. And you can count on those kind of things happening, as things progress and we get feedback from the field. We can start doing things like, okay, let's make some modifications to this firmware to meet this new application. So keep that firmware and software up to date. It is not just about the gear. It's about the inevitable change that you're going to have to build for to ensure that long-term system value and adaptability. And so that's pretty much all I got on that one. I know we started 7 minutes late. We only got like 5 minutes left to go, but I do want to open things up if anybody's got any questions on that.
Mark, we do have some questions.
All right.
Got some good ones. We got one from Chris. On System 20 Pro, my main hangup is the 2.4 gigahertz frequency band. I'm concerned about the reliability of wireless microphones in this spectrum, especially in environments with a lot of potential interference. We all know how crowded the 2.4 gigahertz band is with Wi-Fi, Bluetooth, and countless other devices. Add in the signal loss from a room full of people, and it feels like a high-stakes gamble. So to kind of take that further, basically what would be the best practice for deployment? And really, we have some pretty good examples of how System 20 works in even really challenging environments. So I'll let you go first, and maybe
So first of all, that's a great question. And it's one I get a lot. Now, System 20 Pro is based on the technology of System 10 Pro, based on System 10. And this actually goes back 12 years or so. This has actually been out for a while, so this isn't entirely new. One of the reasons that we've been able to succeed where others have not, even in busy RF environments, is because we use that adaptive method where we're constantly moving. That's one part of it. What I didn't mention is that primary and secondary frequency. They're extremely narrow, and they can actually fit very easily within the guard bands between Wi-Fi channels. Now, in a typical environment, I'm sitting here right now. If I were to light off a spectrum analyzer and look at it, what I would see is a very strong Wi-Fi channel, one that is not quite as strong, and then another one that's very weak. And what that is that's the different zoned approach to Wi-Fi coverage. There'll be, the Wi-Fi access point out in the hallway. There's one in here. There's another one in service behind us. And those are the different levels you see. The name of the game is signal to noise. Now, you mentioned what happens to RF when you get a whole bunch of people in a room. Well, that's why we made System 20 so that you could remove that send and receive unit and actually put it up like in the ceiling. So if you put it up in the overhead, you put that above all of those water bags, all those bodies, that's going to help you get past the problem of absorption and still be able to keep that good signal to noise. We have a very efficient system. When we moved from System 10 to System 20, we actually made it efficient even one step again. So System 20 actually uses half the spectrum that System 10 Pro did before it. And in some cases, actually, if you're in a high density mode, it's actually a quarter. So I can run around with two 1 megahertz signals that I can slide in all through that crowded spectrum and support 4 microphones on just those two little frequencies. So it is proven to be a very versatile system. Now, there's also some other YouTube videos I think are up there. They should be up there soon, that talk about how that works. Just a little bit more in depth talking about 2.4 gig, because that is a concern that we hear a lot. And even some where there's a video where I'm actually walking out of this room and putting myself in a pretty difficult, almost worst case scenario with blockage and distance to just show you how the system performed in real life. I hope that answered the question.
Yeah. Another question we had was related to voice lift and what voice lift looks like for the 1061 in its most basic format. So to kind of take on that question too. So voice lift, I think, is something that's fairly misunderstood in AV, where we believe that if we have a microphone, let's say we have a 1061 over here. Now I'm within its pickup zone. If we were to bring my audio back into a loudspeaker zone where the microphone is also located, that's really not voice lift. That's reinforcement. What voice lift would be having my voice go to a different loudspeaker zone and lifting it to the volume that I'm speaking at. So that way I'm heard more equally throughout a space. So we hear a lot more about like meeting equity. What voice lift is really a form of local meeting equity in order to accomplish that. So that's how that can be done, very generally speaking, in the 1061. But the thing to note about that would be if you enable voice lift mode, that disables the internal AEC in the microphone. So if you were using this in more of a hybrid local discussion, but also sending audio for video teleconferencing, the AEC, the acoustic echo canceling, would have to be offhanded to another device. And those devices could be like a QSYS, DSP, biamp, Symmetrics, like any standard DSP. Or you can use an Audio-Technica smart mixer like the ATDM 1012. So that would be one of the ways that you can accomplish voice lift.
One of the things I get on voice lift a lot is I'll have an end user that'll say, I need to do voice lift because some of the people in the room are older and they have hearing loss and they have a difficult time hearing it. Well, that's not really what voice lift is meant for. That is an assisted listening application, and really should be addressing that with assisted listening system, not with voice lift. Because voice lift, as Dan said, that's more of that mild, just lifting it up to that normal level, and its whole point is to enhance clarity, not to reinforce and to make things louder.
Cool. I'm going to mention something else here too. Because we really don't have a whole lot of time left, we're over. So thanks for giving us extra time here. Say something to work off of what you were talking about earlier with System 20 Pro. One of the concerns about System 20 Pro, in that it operating at 2.4 gigahertz, of course, is where it's going to find channels if you already believe it's, pretty crowded environment. We were operating System 20 at Infocom this year, and that's about the worst 2.4 gigahertz environment I can think of.
I got like 150 feet out of it, and
Yeah.
that wasn't even really line of sight because I started getting blocked by other booth walls and stuff. So
Yeah, we had other 2.4 gigahertz type devices in our booth, and those were having a difficult time really connecting to our PC. But System 20 was operating exceptionally well.
actually, it was so bad that we were having difficulty with the Bluetooth connection
That's it.
to our laptop that was set up in there from our Bluetooth keyboard and stuff. But the System 20 was performing just fine.
Okay.
Well, I think that's it. I appreciate everybody's patience, especially for that little misstep at the beginning there. It's no big deal. This stuff happens. But I really appreciate everybody sticking it out and joining us today to talk about that. This, of course, has been recorded, and hopefully that first part will be edited out, and then we'll get that on our YouTube channel as soon as possible. But thanks again for joining us today, and have a great rest of your day.